Hi, thanks for joining me today. I've got another problem from the Oxford University Maths Admissions Test. This is from the 2013 paper. We want to know what is the degree of this polynomial here. And so it's the second derivative of this guy plus the first derivative of this guy. And we were given four options here, 9, 8, 7, or less than 7. If you want to have a go at this problem, pause the video now and give it a go for yourself. But I'm going to dive right in here. What we're going to do is first consider the degree of this inside guy here. And so this guy here is a quartic, it's degree 4, and this guy here is degree 5. So you multiply them together, that's degree 9. And if I then take the second derivative here, that's going to bring the power down by 2, so that's going to have degree 7. Cool. What about this guy over here? Well, this thing here is a quartic, this guy here is another quartic, because it's x squared and then squared, so that's going to have degree 8. And so when I differentiate that again, I get degree 7. So this is a degree 7 plus another degree 7, and so therefore this must be a polynomial of degree 7. But not so fast. It certainly has to be a polynomial of degree at most 7. However, in theory, it could possibly be a polynomial of degree less than 7. For example, if this turned out to be, let's say, 5x to the 7 plus, lower order terms, and this was minus 5x to the 7 plus lower order terms, and when I add them up, those are going to cancel, and then the degree would be less than 7. So I've just got to consider if that is the case here. So what I need to do is find the coefficients of x to the 7 in both of these. So let's look at this guy here, the first one. Well, what is the degree of x to the 9 inside? Well, this is going to be 16x to the 4 multiplied by minus 1 to the power of 5. Well, that's just minus x to the 5. So that'll be minus 16 x to the 9. And so if I differentiate that twice, the power of x to the power of 7, that's going to be minus 16 times 9 times 8. And I'm not even going to bother to work out what that is. I'll just keep it like that for the time being. Cool. What about this guy? What's the degree of x to the 7 in this thing? Well, let's think about x to the 8 in this guy. That's going to be 16x to the 4 multiplied by 3x squared squared, so that's going to be 9x to the 4. So that's going to be 16 times 9 times x to the 8. And then we're differentiating that. So it's going to be 16 times 9 times 8 times x to the 7, sorry. And so you can see the coefficients are precisely the same, except one is the negative of the other, and so they will indeed cancel out. And so this tells us that the degree of this polynomial will be less than 7. So in fact, it is D here, not C. Now, we can't actually tell what the degree of the polynomial is unless we do some further investigation here. It's not necessarily 6. It could, in theory, be 5 if the x to the 6 terms cancel out as well. But thankfully, we don't need to work that out. We just need to determine that it is less than 7. And that would be our answer here. So a really nice problem, which I imagine lots of students would have just answered 7 and moved on, but you do have to check here. So I quite like this question, purely for the fact that I spotted the trick that you have to check whether the x to the 7s cancel out or not. Anyway, thanks so much for watching. If you have enjoyed this video, please do give it a like, and if you're new to the channel, please do subscribe as well. Thanks for watching. I'll catch you in the next one. Have a great day.